senior electrical engineer, and most importantly today, probably a reliability engineer as well, and has expertise. He's a subject matter expert on ATEX, which is potentially explosive atmospheres, and other topics. So over to you, Steve.
Left and right, and that's the
Okay. Okay, thanks very much. I got the very short straw, last person up for the evening. So I've been asked to talk on a very wide topic, which is electrical system efficiency, safety and reliability. So I thought the best way to do this is to relate to the Rathdrum MSD site. So just an overview of the site here was in 1961, this is a clip from the local newspaper, where there was a hunting lodge on the site bought by two German chemical engineers who started dabbling in chemicals in a old cowhouse or milking parlour at the back of the site. So you can see the hunting lodge here at the front of the site, and it developed over the years as products came in demand, and then as products went off patent, the site sort of went to a standstill and then it would increase again. So over the 50 years it ended up into the scale of the facility that it is there at the moment. As the site grew, there was various different pulls on finances and resources, so the electrical infrastructure may not have got the attention or the focus that it needed. So as a result, in the last 10-year period, there was two significant incidents in Rathdrum. The first one was a fire in our P7 facility, which resulted in a failure of switchgear caused by inadequate protection coordination, which resulted in power disruption to the entire plant and significant property damage. The second incident was an equalization tank explosion. Again, it was an electrical fault. It had inadequate electrical protection and again had significant damage. Luckily, both of these incidents were out of hours, so no one was actually injured in either of them. So that then caused us to focus our attention on the electrical asset and how we should actually be maintaining it. So in most large-scale sites, the electrical system can be considered as the backbone of all activities on site. So it should fall under three main headings. So we look at the safety of the asset to make sure it represents no hazard to personnel or users interacting with the system. We need to look at reliability and continuity of supply to make sure it doesn't inflict any serious losses to production. We also need to look at efficiency and protection of the asset to make sure that we've no inadvertent abuses or incidents. So Merck policy is to look at safety first. So we'll just have a quick overview of safety, how it is relevant to Ireland. So in Ireland, there's actually three different legislative frameworks to do with the safety of your electrical system. So we've the Health and Safety Authority, the Commission for Energy Regulation and the Local Fire Authority. All of these are brought together into the legislative framework, and the national rules for the electrical installations then are published through the ETCI. So if there's a serious accident or incident on any facility, if the unfortunate situation where the health and safety inspector arrives, the first thing you'll look to see is your safety statement, which we learned the hard way. And in particular, since 2014, they've now put particular emphasis on periodic inspection and testing of the electrical system. So here's some statistics. We've over 32 workers killed in fatal incidents from the period 2000 to 2009. These range from different cases across an electrical distribution system, from overhead lines to fixed apparatus, cable wiring systems, power transformers, etc. One of the most serious risks associated with any electrical system is the electrical arc flash. What is an arc flash? It's an explosive release of energy caused by an electrical short circuit. So arc flash injuries range from minor burns to third degree burns, equipment damage and plant shutdown. and it's estimated that as many as 80% of electrical injuries are as a result of arc flash rather than electric shock. So how we address this in Rathdrum, we conducted an arc flash analysis using a software model. That gave us peace of mind for compliance with industry standards. We were able to identify the magnitude of the electrical hazard. It helped to develop a safety program to mitigate risks with the electrical equipment. This involved identifying the arc flash levels of any of our switchgear. We also implemented the correct PPE for our maintenance crafts and the appropriate electrical tools. So this is just a snapshot of a single line diagram from one of our substations. In addition to the arc flash analysis, you can get load flow, capacity and protection coordination and a number of other uses. So an advantage, a centralized source of electrical data and drawings. You can do expansion planning, equipment sizing, analysis of load flow, reliability and so on. From that then we move for efficiency and protection of the asset. So the protection coordination. What the protection coordination does is make sure the relays disconnect in the fault that safely limits the fault energy and is within capability. The discrimination is adequate and the relays perform at a minimum fault level. So this is just an example here of 3 circuit breakers. Sorry. So this is how protection coordination should look. The 3 graphs here are lined up beside each other. If these graphs were crossing over at any point, it would mean that the fault wouldn't be cleared at the point of fault, it would be cleared upstream, which would have a much larger impact on the facility. So simple principle, that's just a small graphic here of another section of the distribution in Rathdrum. If we have a fault here at point A, we want the fault to be cleared here, not up here, which is, if it was cleared here, it would let much larger levels of energy through to this section of the plant, which you don't want to happen. So you may ask, how could these settings be wrong? So your electrical system is an ever-evolving asset as production demands change. It's constantly being modified to accommodate new plant and processes. It can happen that significant loads are added without appreciating the impact on the overall system. So every time you add on something new, you need to really have a look at your complete electrical flow. So load flow analysis, we've talked in detail today about the kilowatt loading on each section and where your energy is going. What a software model will allow you to do is look at the stresses on your system due to wattless power. So you'll be able to see the actual useful power distributed on your system against the actual active power that's being transmitted. Can also be used for sizing of cables and switchgear and examining the impact of changes before they're made on the system. So reliability or continuity of the supply or resilience in the electrical supply. So a model for continuous reliability used at Rathdrum. At the top here we have the gold standard, which is to get the asset management, and in order to get there, each of these steps along the way need to be satisfied. So the consequences of poor reliability in Europe, equipment downtime and failure 64 billion, waste in production 45 billion, production downtime 36 billion and labour impact at 5 billion. Again, relate back to the 2 incidents we had in Rathdrum. The first incident was in excess of 800k and the second one cost us in excess of 600k. Both of those were avoidable if the system had been looked at in a more holistic view. So key elements of the electrical reliability. You need to have someone on your facility with in-depth knowledge of the existing electrical infrastructure, a power quality analysis as energy efficient changes are made, detailed system modelling and risk assessment using the IEEE standard. Some problems encountered at Rathdrum. Over the past 10 years, we've had a strong focus on energy efficiency and energy reduction. And these are some of the spin-offs from that. Failure of mission-critical electrical systems, computer electronic equipment damage, data loss due to servers locking up, nuisance tripping on circuit breakers, capacitor bank failure, transformers and cables overheating. Just an example there would be here on this one, a neutral cable overheating, because when the infrastructure was originally designed, these were all motive inductive loads. So the neutrals were quite often undersized at the main supplies. Then as energy efficient projects come on stream and more electronic equipment gets added, it's put stress on the neutral. So what happened in this situation here was the neutral cable overheated and it burnt off at the point of common coupling. And it was a 3-phase supply using all single-phase loads, so that caused a shift on the start point, which created voltage imbalance on the system, and none of the circuit protection worked, so most of the electronic equipment actually failed, which caused significant downtime. Okay, so here's an overview of our electricity monitoring system. It was installed for energy efficiency, which it did, saved 6 gigawatt hours there over a couple of years. The increase here on the right hand side is due to increase in production. That's a quick overview of the system that we put in. When we installed the system for energy reduction, we also installed it to alert for power quality issues or power factor on the system, which has proved to be very beneficial. Added benefits, harmonic analysis assisted in preventive predictive maintenance, and we were able to determine the frequency event, and we were also able to size power conditioning equipment. Another benefit here is this should be a continuous sine wave. As you can see here, we've got surges from equipment, and 80% of this type of interference is generated within a production facility. It's not actually coming from the electricity supply. Another example of graphs that were taken from the system shows voltage sags and swells from inrush of motors in the area. Reliability evaluation here from the IEEE standard is one of the best methods of doing it. So where the Rathdrum facility got itself was from a firefighting situation here on the right hand side across to between optimization and reliability. This was done without any increase in maintenance headcount, and just by restructuring the way we were doing our business. The reliability solution, so your solution investment should be rated against your plant availability requirement and the cost of unplanned downtime and the power quality capability on your system. MSD Rathdrum, we hosted a visit from the regulators across all the European states who came to see and commented on the exemplary standard of work that's currently now happening at the facility. They also did a design comparison between a hydrogenation facility that was built in 1988 and one that was built in 2010. So key takeaways: safety of the asset, do your arc flash assessment and appropriate electrical PPE. The resilience or reliability of your supply, efficiency and protection of the asset, and a site-wide overview. So holistic approach should be taken to your plant every so often. Thank you. And sorry for rushing it.